Hello everyone, welcome back to the channel. In the previous videos, I had discussed about the Boolean expressions, that how can we represent them in the standard form and how can we use the Boolean algebra to minimize the Boolean expressions. In this video, I'm going to discuss another technique which is also used for the minimization of Boolean expression, which is known as Karnaugh Map or simply the K-map. These K-maps are very useful for the Boolean expressions minimization, since it's more easy to solve the minimize the Boolean expression using K-maps in comparison to the use of Boolean algebra in case of the complex problems. It is a graphical method which is used to simplify the logic equations, or we can convert the truth table into its corresponding logic circuit by use of the K-maps. This is a simple and systematic technique which can be used to solve any number of any problem having any number of input variables. But its practical usefulness is actually limited to the 6 variables, and more specifically, they are easy to solve up to 4 variable problems. Now let's discuss that how we have the format of K-maps. How the K-maps look like for different problems. Different problem means for different number of variables. So it's a graphical representation of output level of a Boolean function for each of the possible input combination. Now what I mean to say, that if we have a 2 variable problem, then how many possible combinations are there? 4. Now what I mean to say, that if we have 2 variables a and b, now a and b both can be 0 0, a0 b1, a1 b0, and both can be 1 1. So we have 4 possible combinations, and corresponding to this we will write the output corresponding to these. So this one actually represent minterm 0, minterm 1, 2 and 3. So in K maps, how many cells are there, that is decided by that how many variables we have. Like in the 4 variable we have 2 variable we have 4 possible combinations, 3 variable 8 combinations, 4 variable 16 combinations. So how many combinations are there? That number of cells are there in the K map. So if we have a 2 variable problem, then the K map looks like this. It will have 4 cells. Each cell is there for each minterm. Each cell is there for each minterm if the expression is written in the form of SOP. Now on this side we will write the MSB, and on this side we will write the LSB. Now A can have the value 0, A can have the value 1, B can have value 0, B can have value 1. So when A and B both are 0 0, this one actually represents minterm 0. A0 B1 minterm 1, A1 B0 minterm 2, A1 B1, this is minterm 3. So this one is the representation of 2 variable K map, which are quite easy. Then if we have 3 variable problem, then for 3 variable problem we will have 8 possible combinations. So the K map needs to have 8 cells. So this is how it looks like. 3 variables A, B, C. Again we will write MSB on this side and the remaining on this side, remaining variables. Again A can be 0, B can be 1. Now since on this side we have 2 variables B and C, now they can have 4 possible combinations. Now we need to write all the 4 combinations for leveling the columns of this K map. Now, what we need to keep in mind over here that the leveling of K-maps that uses the gray code. Now, why we need to use gray code? Because what is the requirement for the leveling of K-maps? That when we are moving from one cell to another cell, there should be variation in only one of the bit. So 0, 0, 0, 1. Now, in general, if we write 0, 0, then we write 0, 1, 1, 0, 1, 1. So if you look over here, this one is changing, this one is also changing. Both the bits are changing. But if we write the gray code, the same time 0, 0, 0, 1, 1, 1, 1, 0. Now here there is change in only one bit, this one, when we are moving from one cell to another cell. So what is used in the K maps? We use the K maps for the leveling. Now let's write the different minterms. A0, B0, C0, this is minterm 0. A0, B0, C1, minterm 1. A0, B1, C0, this is minterm 2. A0, B1, C1, this is minterm 3. A1, B0, C0, minterm 4. 101, minterm 5. 110, minterm 6. And 111, this is minterm 7. So corresponding to this, the expression will be A complement. This is A. This one is B complement, C complement, B complement, C, BC, and this is BC complement. So you can use like this in the form of 0 and 1, or you can write it in the form of the variables either in their complemented form or uncomplemented form. Now let's see the 4 variable K map. 4 variable, let's say the 4 variables are A, B, C, and D. 4 variables means 16 possible combinations. Now the K map will have 16 cells. 16 cell means 4 rows and 4 columns. So this is how an empty K map looks like. AB on this side, we always start with the MSB and CD. Now again, since on the row side we have 2 variables, so it will have 4 possible combinations. The requirement for the leveling is that only one variable should change at a time. So 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Now let's write each of the min term or the max term corresponding to each cell. So 0, 0, 0, this is 0, 0, 0, 1, 1, 0, 0, 0, 1, 0, 2, and this one is 3, 0, 0, 1, 1. 0, 1, 0, 0, min term 4, 0, 1, 0, 1, 5, 0, 1, 1, 0, 6, 0, 1, 1, 7. Now if you just need to look at 8th, 8th is over here because 1, 0, 0, 0. 8th, then if you look at this cell over here, then this is the 9th, because corresponding to this on this side we have 1, 0 and this is 0, 1. So 1, 0, 0, 1 is min term 9. This one is 10 and this is 11. 1, 0 and 1, 1 on this side. 12, 13, 14 and 15. Now these are the empty K maps where we have leveled each cells. Each cell where we have written 0 to 15 in this case, they are the cells corresponding to each min term or max term depending upon what type of Boolean expression we are given with. Now these K maps, they can be used to obtain the simplified Boolean expressions both in SOP or POS form depending upon what is given to us. Now what to do if we are given with the Boolean expression? Let's say the Boolean expression is given in form of SOP. So what to do after this? First thing is we need to write the standard SOP expression. If it is given in standard form, it's well and good. If it is not given, then we need to change the expression into standard SOP form. After this, we need to fill the appropriate cell of the K-map by placing one in each cell corresponding to a term given in the expression. Let's say we have a three variable K-map. The three variable K-map is given, problem is given to us like y is equals to ABC plus A complement B, A complement B, C complement. Now this is already given in standard form. This one is minterm 7, this expression. This one is 0, 11, this is minterm 3. This is 0, 1, 0, this is minterm 2. So they are already given, so we can write the expression. It's a sum of minterms 2, 3 and 7. So in K-map, what we need to write on this side A, B, C, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. In this expression, minterm 2, 3, 7 are given, means we need to write 2, 3 and 7. Like place the ones corresponding to the minterms which are given in the expression. Now once we write this, after that we need to do the grouping of the ones. We need to do the grouping of cells. Now once all the minterms are placed, we need to do the grouping of minterms in the cells. Now this grouping, it can be the grouping of two ones which will lead to a pair, or a quad if we have four ones altogether, and if we have eight ones altogether, then it will lead to octet. Now all these ones, they should be adjacent ones. Adjacent means they can be there vertically or horizontally. So they can be grouped all together. Even the combinations are possible by any side folding. It's possible by any side folding as well, but the grouping is not possible diagonally. It's not possible diagonally. So let me show you the different grouping options, and maximum number of groupings are possible in case of four variable K map. So let's discuss in that one, that what are the different combinations possible. So in this case, I'm not going to write any levels or variables, just trying to show you that what are the different possible combinations. Like if we have minterms placed like this. Now what's possible? That we have four ones over here, they are making an octet. There are two ones over here, we can make the pair. Now if we just look at this one and this one, they look like they are the individual ones. But if we fold this K map, then these two can be combined. So this is one possibility. But at the same time, if we have any one over here, and you think that you can make the pair like this, no, this is not correct. This is the wrong combination. It's not possible. It should not be there. They can be, the combinations can be made by horizontally, that is a row wise, column wise, that is vertically or by folding from any side. Like if I fold all the four corners and we have a possibility that there are ones in all the corners, then again we can make the chord from the corners, but not diagonally. So when we what we need to remember over here, then we are while we are doing the grouping, that overlapping is allowed. We can consider one of the minterm many times, but there should not be redundant pairs. Now, what I mean to say by redundant pairs, like if this is the case, we have already marked all the ones. We have already covered all the ones. Here we have a quad. This is pair and this one is pair. And if someone is thinking like that, we can also make this pair. There is no need of this pair since both the ones are already covered in the different pairs. So if you make this one, this is a redundant term which is not correct. So these are the things which we need to keep in mind. So if we have expression given in the form of POS form, that is product of sums, then what to do in that case? Again, we need to we need to make same type of K-maps. Like if again I take the example of four variable problem, same K-map A, B, B, C, sorry, C, D, not B, C, C, D, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. This one is 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 15, and 14. This is how the empty K map looks like. So if the expression is given like y, which is function of a, b, c, and d, let's say the max terms involved are 0, 3, 4, 5, 9, 8, 9, 10, 12. So what it means, corresponding to these cells, we need to place the zeros because this is given in the form of POS, product of sums. Product of sums means corresponding to the terms which are given in the expression Boolean function value is actually 0. So we have to write 0 here, then 3, 4, 5, 8, 9, 10, 12. Now again, in this case, same combinations are possible: pair, quad, octet. And we always need to look for the octet first, whether there is any octet possible in the K-map. Now, whether this is the K-map for the minterms or for the max term, we always need to look for the octet. If octet is not there, then we need to look for the quad. And if quad is not there, then we need to go for the pair. So our first priority is always making the combination which is have maximum number of the terms involved. So that one octet is the first priority, followed by quad, and pair is the last option. Now in this case, if we just look at the combinations, then there is a quad possible. Now we don't have this one is pair. We don't have any one zero adjacent to this. Even this one, there is no possibility of any combination to this, so it will be an individual zero. When we look at this, now if we fold this towards this side, from here to this side, then the possibility is that we can combine minterm 8 with max term 8 with max term 10. So now here we can say that this max term is used in three different combinations. But why we have used this in three different combinations? Because we were having the individual zeros. Firstly, we have used in octet, then we have one individual zero lying over here. So there is possibility to make the pair instead of keeping it single. Then same is over here. Then this max term 10, it can be combined with 8 in order to make a pair instead of keeping it single. So in this way, you can use the min term or max term multiple times, provided that you have the another min term or max term which is lying single. So this is how we can make the different combinations in the K maps. In the next video, I'm going to take the examples of K map problems for the SOP expressions. If you think this video is helpful, then keep supporting the channel. Do like and subscribe to the channel and share with your friends. Thanks for watching the video.